Chemical equilibrium is the state reached by a chemical system when the rates of forward and backward reactions become equal. Let us examine a chemical system to see how a reversible reaction can reach a state of dynamic equilibrium. The forward reaction of the system is the decomposition of dinitrogen tetroxide into nitrogen dioxide. The backward reaction is the combination of nitrogen dioxide into dinitrogen tetroxide. When a small amount of dinitrogen tetroxide is introduced into a sealed container kept at 40 degrees Celsius, the liquid immediately vaporizes. Then the forward reaction, decomposition, occurs quickly. This is because the concentration of dinitrogen tetroxide is at its maximum initially. As time passes, the concentration of dinitrogen tetroxide decreases and the concentration of nitrogen dioxide increases. The color of the gaseous mixture turns from colorless to pale brown as nitrogen dioxide forms. As the concentration of dinitrogen tetroxide decreases, the rate of the forward reaction becomes lower. Meanwhile, as the concentration of nitrogen dioxide increases, the rate of the backward reaction becomes higher. Eventually, the rate of forward reaction and the rate of backward reaction becomes equal. The concentrations of reactants and products no longer change. They remain unchanged because the reactants and products are being consumed at the same rate as they are being formed. A small amount of nitrogen dioxide is introduced into a sealed container. Then the backward reaction, combination, occurs quickly. This is because the concentration of nitrogen dioxide is at its maximum initially. As time passes, the concentration of nitrogen dioxide decreases and the concentration of dinitrogen tetroxide increases. The color of the gaseous mixture turns from a dark brown color to pale brown as dinitrogen tetroxide forms. As the concentration of nitrogen dioxide decreases, the rate of the backward reaction becomes lower. Meanwhile, as the concentration of dinitrogen tetroxide increases, the rate of the forward reaction becomes higher. Eventually, the rate of forward reaction and the rate of backward reaction become equal. The concentration of reactants and products no longer change. They remain unchanged because the reactants and products are being consumed at the same rate as they are being formed. We should note that the equilibrium state can be reached from either direction of a reversible reaction.